Okay, good evening, everyone. We had left at this question and I had labeled this as homework. I'll present you a way to solve this question.
So using recurrence, no?
Yeah, you can solve it using recurrence. Is my screen not visible?
Sir, on your phone, iPhone or iPad, this screen is full.
One second. Yeah, the answer to this question is 20. And the way to solve it is that you first look at this first equation. Ax plus by, if you multiply x plus y to this, you will find that it becomes ax square plus axy plus byx plus by square. If you rearrange it, one second, please. So here, if you rearrange this a little bit, you'll find that ax square plus by square is equal to a plus b times xy. So this is not only true for this first equation. You can see that from ax plus by, you got the next term ax square plus by square, and the previous term which is not actually given. If you see this pattern going on, if you like extend it backwards, it should look like a plus b and then a upon x plus b upon y, because x is getting multiplied to a and y is getting multiplied to b and so on for these terms. So you can sort of write an equation that ax to the power, let's call each of these equations S1, S2, S3, S4, and this finally to find will be S5. and you can write that Sn times x plus y is equal to Sn plus 1, which is the next term, plus xy times Sn minus 1. So this is probably what the recurrence relation Sumit was talking about. And from here you can get two equations. 7s is equal to 16 plus 3p, because I can replace x plus y with some s and xy with product p. And the next equation that I can write down is 16s is equal to 42 plus 7p. And what we actually want to find is answer plus 16p is equal to 42s. This is the third equation that we'll have. If you multiply by some quantities alpha and beta around here, and say that let's call this first equation something L, and the second equation L2, and then alpha L1 plus beta L2 must become this last equation. This can be done because linear equation manipulation is possible by doing a linear combination of both these equations. So you can get another equation. If you want, just take a screenshot of whatever I'm writing and try to make sense of it later on. 7 alpha plus 16 beta will equal 42. You have another equation, 3 alpha plus how much? 7 beta equal to 16. From here, if you solve this, you will get alpha equal to, how much was it? 38, and beta equal to minus 14, which you can substitute to get 16 times alpha plus 42 times beta is equal to 20. So you can just take a screenshot of this if you want, and then later make sense of it. We'll start today's class with a new question.
So please show the homework question.
Last time's homework, no? I'll show it later also after the class ends. You can also watch the recordings on YouTube. It's available. Uh, let's start with question number 9. Question 9, I will not solve immediately. Instead, I'll keep it as a bonus question which will be discussed at the end of the class. Okay, you have an equation 2 to the power 333x minus 2 plus 2 to the power 111x plus 2 is 2 to the power 222x plus 1 and finally plus 1. This equation is said to have 3 real roots. You need to find their sum. Okay, so this is what you have to do. But question 9 is a slightly tough question which will not be solved right now. You guys can try attempting it. If you get the answer, send it in the chat. Say that question 9 and whatever answer you get. Uh, rest of you who can't understand question 9, or actually everyone should start with question 10.
Which class of
Which class? What happened? Everyone is requested to start with question 10. Once you are done question 10, you can proceed with question 9. Okay, first do this. There is a cubic equation which has roots alpha, beta, gamma. Find alpha cube plus beta cube plus gamma cube. Today's most of the content is going to be beta. question 10, everyone can start with. If this equation has roots alpha, beta, gamma, find alpha cube plus beta cube plus gamma cube. Question 10 may I'll give a certain amount of hints.
Sir,
First of
please
all,
don't.
if you're not aware of the theory, I'll just mention the theory. Other, I'll not proceed with solving the question. See, here the theory is relevant theory.
Sir, 15.
Okay, don't shout out the answer. Just put it in the chat. Everyone has access to the chat. Uh, put it in the chat. I'll mention whether correct or not correct. Theory is that if you have a polynomial ax to the power n plus
Sir,
bx to
my
the power
answer is
n
correct.
minus 1 plus c. I can't see your answer in the chat. Try resending it. Send it to me instead of Sumit, correct. So sum of roots is equal to minus b by a. Sum of product of roots taken 2 at a time is c by a. Sum of product of roots taken 3 at a time is minus d by a, and so on. If your coefficients continue in an alphabetical order. So if they're asking you to find alpha cube plus beta cube plus gamma cube, you can make use of the fact that from this, for this polynomial, alpha plus beta plus gamma is equal to, this will become hint, 0 upon 1, alpha beta plus beta gamma plus gamma delta, sorry, gamma alpha is equal to minus 6 upon 1, and alpha beta gamma is equal to minus of minus 5. Okay, all the relevant stuff with for this question has been written down over here. The theory is that if you have a polynomial, the sum of all the roots, not necessarily all the real roots, all the roots in existence in the polynomial will be of the form minus b by a. Sum of product of roots taken 2 at a time. For example, a, b, alpha, beta, beta, gamma, gamma, alpha. Only 3 such combinations are possible. All their sum will be c by a, and product of roots, sum of product of roots taken 3 at a time, only one combination alpha, beta, gamma is available. That is minus d by a. So in this case, it will be 5, and this is minus 6. So using this fact, alpha plus beta plus gamma is 0, alpha beta, beta gamma, gamma alpha is minus 6, alpha beta gamma is 5. Try to find alpha cube plus beta cube plus gamma cube. Alok, try again. Pushkal, try again. Not correct.
Sir, sir, is the answer correct?
Ayana, correct.
Sir, is the answer correct for Keshav Singla?
Keshav, I don't think I have received your answer. Send it again. No?
Sir, I
Send
have
it to
already
Aditya instead
said
of
30 LPS.
send it to my ID, Aditya. Arnav, not correct. Try again. Pushkal correct. Vedang correct. Keshav correct. Okay. So here, instead of going through the tough route of actually making the whole cube of this and sort of removing out stuff from here, we can recall a very useful identity, and its usefulness is tested in such times only. You know, a cube plus b cube plus c cube minus 3abc can be factorized as a plus b plus c times a square plus b square plus c square minus ab minus bc minus ca. Correct? Uh, this this identity itself can be shown if you take alpha plus beta common here and c common out from here and then do some more manipulations. In the end, you get that this expression can be factorized into two terms. Out of these two terms, a plus b plus c, whenever this goes to 0 or this other term goes to 0, whenever that happens, you can directly equate these two. And coincidentally, in this question, the sum of the roots is 0 because the x square coefficient is non-existent. So directly, you don't need to actually do any more effort. You can directly write, since alpha plus beta plus gamma equal to 0, we can write alpha cube plus beta cube plus gamma cube is equal to 3 alpha beta gamma. And this is already known from Vieta's identities, that sum of product of roots taken 3 at a time, alpha beta gamma, is minus of minus 5, which is 5. So you're left with 3 times 5, which is 50. And this will be your answer. There is no actual need to find all the roots for this equation. Although, yeah, I think they all are not integers. It doesn't matter if they are integers or not. The product will be directly found from. Okay. Try question 11. You can take a screenshot of this. Use the ideas that I presented for question 10 to solve question 9. And if no one sit idle. I'm sure that question 9 will stump most of you. So uh, try thinking whatever can be done. There is a very neat substitution that can be done. After that, you have to use a very brilliant thought process to actually get their sum only. Okay. And it's related to very simple stuff that you have learned probably in 6th or 7th grade also. Uh, but that substitution, and after that, that stroke of genius, that is only required for this question. Okay. Question 11, everyone can try attempting. I hope everyone is uh, aware of what complex numbers are. Even if you are not, doesn't matter. The thing is that there is some function f such that when you put x by 3 inside it, you are left with x square plus x plus 1. Now, you have to find all x that belongs to complex numbers. Don't read too much into this. It's just basically saying that whenever you write a polynomial down or a quadratic equation, polynomial, anything, it has roots that are complex by default. Okay. Your real numbers are numbers that can be representable on a number line. Correct. So you have 0, you have 1, every number in between, and then everything there. Complex numbers include all the real numbers and are of the form a plus ib, where this I
Sir,
is the imaginary square root of unity.
my answer correct for the ninth question.
One second. Sumit, not correct. Try again.
Sir, ninth.
Ninth, not correct. Try again. Okay. So Yeah, where was I? So complex numbers are basically, they contain all real numbers. When you put b equal to 0, you are left with a only. Here a and b belong to all real numbers. Okay. So whenever I say, whenever I talk about this sum of roots or sum of product of roots taken 2 at a time, 3 at a time, I mean all the complex roots included. Sometimes equations don't have real roots. For example, try plotting this equation itself. You might have heard about some software, GeoGebra or Desmos. Try plotting this exact equation, or just try plotting y equal to x square plus x plus 1. If you try plotting this, you'll find that this never will intersect the x-axis. This doesn't have real roots, but it will have roots that exist in the set of complex numbers. When I talk about Vieta's identities, these statements are true for all the roots for your equation. So that is all the background for this question. Uh, don't read too much into this. Just try to find what will be the sum of all x such that f of 3x is equal to 7.
Sir, I made it, sir. I made a spelling mistake. Sir, is it correct?
1 second. Arnav, not correct.
Sir, for the ninth
Sumit,
one, for
not.
the ninth.
Sumit, not correct.
Sir, nine.
Uh, yeah, not correct. Anya, not correct. Try again. Arav, yeah, answer is not correct. Acha, if you are confused about this question, first of all, just try to find what f of x is. Once you have that with you, Purbayan, I think you are on the right track, but you missed something very important for this question. Uh, Try that question once again. Uh, Jivana, not correct. Try again.
Sir, is answer of Keshav correct?
Keshav, not correct. Try again.
Sir, answer.
Okay, everyone try to do this intermediate step, right? Try to find f of x itself and send it in the chat. I will check if you have found it properly or not. Anya, I'll like give solution for question 9 later on. Sumit, that is not correct. Purban, very good. F of x that you have found is correct. Now find f of 3x, equate it to 7, and then find what will be the sum of the roots. Okay, in the interest of time, I will find f of x and give you f of 3x, sorry, f of x upon 3 is equal to x square plus x plus 1. Now, x over here is called a dummy variable because its value actually doesn't matter. This function has a certain other representation. When you put the value x upon 3 inside it, you get a neat equation like x square plus x plus 1. So what you can do instead, what value should you put instead of x over here so that it
Sir,
looks like f of x?
sir, is my answer correct for
Sumit, not correct.
the for 11th?
11th one, not correct. Try again.
Sir, is answer of Keshav the for 11th.
Uh, Who else has answered? No one else has answered. See, send the message to me, Aditya, instead of Transition Lab Preparatory School. Arav got the answer. Very good. Correct. So from here, if we replace x with 3x, what we get is f of 3x upon 3 is equal to 3x the whole square plus plus 3x plus 1. And this is 9x square plus 3x plus 1. And this is f of x only. So half the question is done. You have found what f of x is. Now you have to find f of 3x and equate it to 7. And you will obviously get a quadratic equation. Find roots for that quadratic equation. Jeevana correct. Purbayan correct. Very good. So from here you can see that f of 3x, sorry, 3x equal to 7 implies that how much? 81x square plus 9x plus 1 equal to 7. If you bring 7 on the other side, you get 81x square plus 9x minus 6 equal to 0. Okay, you can take a 3 common out from here and do the other stuff. Probably use the quadratic formula, get the roots. All of that is unnecessary. Simply sum of roots. Whether they are positive or negative, whether they're real, they are complex, doesn't matter. Sum of roots is directly minus b by a, and that is minus 9 by 81, which is minus 1 by 9. And this is the answer. Okay, is this clear to everyone? Anyone has any doubts? You can ask. Arav is asking, see the recording of this session, as far as I know, sometimes is uploaded to YouTube, sometimes it's not. Today, I can see that it's not being streamed.
So which
I
channel
don't.
is it uploaded to?
You can just search Transition Lab Preparatory School channel, and there are recordings of the previous sessions available over there. Question 12 can be attended. But to be on the safe side, I suggest that everyone takes a screenshot of this, because I don't know if any other way you'll be able to get the recording. So since today's class is not being streamed on YouTube directly, try question 12. This also has a similar idea involved. There is a cubic equation 8x cube plus 1001x plus 2024 is equal to 0. This is a cubic equation which has roots s, r, and t. You have to find s plus r the whole cube, s plus t the whole cube, r plus t the whole cube.
So number 10.
Sumit, very good. Correct.
So let's for that question. Not this one.
Whatever.
So let's for that question, first question, not this one. My answer is for
Correct. I recognize the answer now. After like 2-3 minutes, I will write down the equations that concern sum of roots, product of roots, sum of product of roots taken two at a time for cubic equations. And then you can see something pop out of there. Are very close but not correct. Arav, I've changed the question a bit. Anya, answer correct. Jeevana,
so
class
what's the
will
change?
extend till 6:10. Huh?
So
What are
what's
your notes?
the question? What's the
Question
change?
is, there is a cubic equation with roots s, r, and
Yeah,
t.
told that there is a change. What's the change in the question?
No, so this is based on a old AMC problem which had 2013 in it instead of 2024 or some other number. I don't remember. 2008 probably. See, always remember AMC exam at some point the number 2024 will appear in the paper. So whatever questions you solve, try to replace the year dates, years. Like it can be all the way from 1950 to 2023. Past year papers questions if you're solving. Try to replace the dates with 2024 and reattempt the paper. Sometimes it might not work. Sometimes it might depend on the divisibility of the number in question. But most of the times in geometry, the year date is irrelevant. You can just replace it with any odd number, any number, not necessarily odd, and it will question will still work. Sumit, not correct. Try again. Arav, question is answer is like wrong from the perspective of sign. Otherwise, it's correct. Okay, I'll write down the relevant equations for this question. See, Vieta's identity says that the sum of roots. There is no quadratic term over here. The non-existence of quadratic term directly states that S plus R plus T equal to 0 as coefficient of x square is equal to 0. Then SR plus RS plus, sorry, SR plus RT plus, I'll write everywhere T with this stylized form. This is equal to 1001 upon 8.
So these questions are a big.
1 second, yeah, Arav answer is correct. Sorry. Anya, you just check your answer.
So excuse me, sir.
Yeah,
So for which grade is this class?
for 10th and 12th, AMC 10, 12 targeting.
So that's why we are weak by questions are being solved.
What
Because we
happened?
are
See, I'm just doing previous AMC 10 questions. Sumit, not correct. Okay.
Sir, we are from sixth class, so that's
Sir,
why we are.
still we were
Okay.
able to solve question 9 and 10.
9 you
11.
solved?
Sir, 10 and 11.
See, once you know the concept, every question is doable. It's not about a particular grade or anything. There are 9-year-olds, 10-year-olds who are in college, but they're one-off situations. ठीक है, तो doesn't matter. Here you are supposed to find SR the whole cube, S plus T the whole cube, and R plus T the whole cube. Uh, the way to proceed over here is not to actually expand this. Just because you know a plus b the whole cube doesn't require to expand all of this. You can write that s plus r is equal to minus t. Same way you can write r plus t equal to minus s, and t plus s is equal to minus r. And when you substitute these values, why can we write all of this? Because the sum of roots is 0. Once you substitute them back inside here, you find that the question is asking you minus t cube minus s cube minus r cube. And if you take the minus sign common, you find that this is 3 srt, and that is equal to minus 3 times minus 2024 upon 8. And that becomes, this minus and minus sign will cancel, and you are left with 3 times 253, which is equal to 759. Is there some error over here that you guys find? Harshit, correct. Arav, apologies for your answer thing. I'll give another question. Try to find the remainder when x square plus 51 is divided by x plus 1. Sumit, correct. Alok, correct. Harshit, correct.
-51 minus x.
No, but okay. Purban, not correct. And moreover, don't shout out the answer. Pushkal, not correct. Jeevana, correct. Harshit, correct. Alok, correct. Sumit, correct. Sohini, not correct. Vedang, correct. Sanyu, correct. Pushkal, correct. So see, the concept that you have to apply over here is that you have a particular dividend
52.
polynomial. One second, don't shout out the answer. No, I'm saying again and again. Put it in the chat. Purban, correct. Okay. D of x, or the dividend polynomial, is equal to the divisor polynomial times the quotient polynomial plus a remainder polynomial. This is same as your dividend equal to quotient times divisor plus a remainder. Okay, the basic Euclid's division lemma. Or when you divide by a divisor, whatever quotient and remainder you are left with. Or this is something you used to call the check rule in a very small class, probably third or fourth. So this same rule is applicable for polynomials also. So if you want to divide x square plus 51, you can do it via long division. First, I'll do it via long division, and then I'll show you a much faster way. So you have x plus 1. Things to remember is that the degree of the remainder polynomial must be lesser than the degree of the divisor polynomial. That is the rule when you do polynomial division. When it is normal integer division, then remainder must be smaller than divisor. Just the difference is that here degree must not, here the degree is important thing, because that's the only way you can quantify a polynomial, the size of a polynomial. Otherwise, it's not easy to compare two polynomials. The degree is the only indicator of the size of a polynomial. So when you divide it, I'll write the quotient here instead of above. So I see that x plus 1 can go once with x square. Now it doesn't matter like long division. Okay, I'll not explain long division in detail, but I'll take x, multiply with this and subtract it. I'll have minus x square minus x, and we'll be left with, this will cancel. And you have 0 minus x plus 51. 51 will be dropped down. Now, this goes minus 1 number of times with x plus 1. So you multiply minus 1 with x plus 1 and subtract it. So you add x plus 1 and you're left with 52. This is by long division, you find that the remainder, of course, if the divisor is a linear polynomial, your remainder will be constant. And that constant value comes as 52. Okay, so this implies answer is 52. What if the question was slightly more complicated? 13b, let's assume. I'll just copy this entire thing. Find the remainder when x, instead of x square, it was a much larger number, x to the power 51. What would you have done in that scenario? Okay. Okay. Few of you know the method. Harshit, Jeevna, Alok, Sanyu, Vedang, correct answer. Arav, correct.
Sir, what is the next question?
Next question is x to the power 51 plus 51 when divided by x plus 1.
Sir, for,
Yeah.
Sir, my answer.
for the previous
Sumit,
question,
correct.
sir, can you explain the long division part again? After, like, yeah, can you explain the long division part again?
So see, long division over here is not like integer long division. So integer long division means you need to you'll never get negatives over here. But in polynomial long division, there is possibility of getting negative numbers up. All you need to keep in mind, what is the largest degree of your current divisor? See, this is the current, the original dividend, sorry, the current dividend. Once you have removed x square, you are left with minus x plus 51. So your aim is to multiply by some number over here, multiply out some number into this. When subtracted by this, you get rid of the largest degree. So iteratively, you are reducing the degree. In normal long division of integers, you try iteratively reducing the size of your dividend, correct? Suppose you are dividing some large number 1729 by 13. So you'll remove thousands place by saying ki I'll have one time I'll remove it 13 and then you'll be left with 4 and then you bring down 2. Then 42 you remove by 39. So here also the process is to remove the largest digit. Here the idea is to remove the largest degree.
Okay, sir.
Okay, now coming to the trick of this question. When we have dividend polynomial is equal to divisor polynomial times quotient polynomial plus remainder polynomial. Divisor polynomial can have roots of its own. For example, when d of x equal to x plus 1, x equal to minus 1 is the root. And since d of x is a linear polynomial, r of x is going to be a constant. So when x is equal to minus 1, d of x equal to 0, which implies our capital dividend polynomial is equal to 0 multiplied by quotient polynomial. I'll be consistent with quotient. I'll just write small q plus r of x. And since this is a product of some polynomial with 0, this entirely is 0. So our dividend of x, I'll just put alpha, will become r of alpha. Since r of x is equal to r of alpha, where alpha was the root of our divisor polynomial, it will equal dividend. We have successfully found the remainder in that case. For this case, it will be R of remainder minus 1 to the power 51 plus 51, which is minus 1 plus 51. So 50. You can try such questions on your own by looking up questions for factor theorem, remainder theorem. This is basically called the remainder theorem, where you insert the root of your divisor into the polynomial, and whatever constant you get in the end is your remainder. Any queries with this?
So basically remainder theorem, right?
This is called remainder theorem. Whenever you get a zero remainder, it becomes factor theorem. So factor theorem is basically a checking method to figure out if your divisor dividend has roots the same as divisor, or does the divisor divide your dividend completely or not. That is factor theorem. Okay, try what question number are we at? 13. Try question 14. Find the product of all real solutions for this equation. Okay, Anya is saying that when we apply same method for last question, answer is different. It won't be different. Check it out. When you put minus 1 inside here, minus 1 square becomes 1. And that should be 51 plus 1. So you get 52 only. Here it's an odd power, that's why it becomes.
Sir, is that mod?
Yeah. So this symbol, mod of x
Acha,
is
okay, sir.
x if x is greater than 0, and minus x if x is less than 0, is also called the absolute value. Arav, not correct. Pranshu, not correct. Saurabh, not correct. Pranshu, you are close to the solution. Just needs a little bit more. Sohini, correct. Purban, not correct. Try again. Jivana, not correct. Try again. Okay, Arav, not correct. Purban, correct. Shreyas, not correct. So far, how many of you have solved it? Sanyu, not correct. Acha, whatever solutions you are getting, try putting it inside the equation and checking whether they make sense or not. Arav, correct. Saurabh, not correct. Okay, Pranshu is confused. I think this will resolve your problem. Think about it. If A is a solution, minus A is also a solution.
So can you check my answer?
Jeevana not correct. Pushkal, there is a very tiny error that you have done. Check again. Harshit not correct. Jeevana not correct. Sanyu correct. Vedang not correct. Pushkal correct. Okay, I'll give a hint. Replace mod x with y. Because unnecessarily it's complicating the look of this question. First of all, what you should do is you should do a whole square. That is the obvious thing. Because why keep two square roots? Why not let the insides of these interact?
Sir,
It's better to take a square throughout. Sumit not correct. Try again. Manraj not correct. Alok not correct. So at the face of it, this question is not very complicated. It's just a bit tricky. You have to keep your mind alert about how to go about doing this question. What I'll do is I'll replace mod x with y. Now, what is x square? Can I write that x square is actually mod x the whole square? It doesn't matter what I put inside the whole square, either positive or negative. It will always be the same. Correct. So I can write x square is actually y square also. And mod x is equal to y. If I do these substitutions inside here and here, basically, this inside here and this inside here, then what I find is that, and take a whole square also, I find that 5y plus 8 is equal to y square minus 60. Now, this is a good old quadratic that can be solved very easily. You have y square minus 5y minus 24 equal to 0. Now, if you jump and say that, okay, product of roots over here is minus 24 and say minus 24 is your answer, you are wrong. What you should do is actually factorize this. Think about what are possible values of y. When you factorize this by middle term splitting, I'll mention that also, y square minus 8y minus 3, sorry, plus 3 y minus 24 equal to 0. What exactly is middle term splitting? You take your constant term, try to break it into two factors that together will add up to give either 5 or minus 5. And then you can split your constant term into those two fractions that you have. So here minus 8 times 3 gives minus 24. If you take y common from the first two, y minus 8, and 3 common from the next two, y minus 8, you find that y minus 8 comes out common and you're left with y plus 3 equal to 0. From here, you can say y equal to 8 or minus 3. These are the roots for y, the quadratic in y. But we have one compulsion. If y is the mod of another quantity, if I draw the graph, this is y equal to mod x. Notice that y is always positive. When x is positive, y is positive. When x is negative, y is positive. So minus 3 as a value is non-acceptable for y. X could be minus 3. It's fine. But when x is minus 3, y will become 3. So from here you get mod x is equal to 8, which implies x is equal to 8 or minus 8. These are the only two possible solutions for x. And when you multiply them, you will get minus 64. At any point, if you have any doubt, you can ask me.
Sir, why it is not possible to take minus 3 as a solution?
For y, because y has been defined. So in your substitution, always remember, okay, when you are substituting something with another thing, you should also keep in mind what are the possible values that y can attain. Can y be a negative number from this definition?
No,
It
sir.
can't, correct? It can't. So that's why this minus 3 is rejected as y greater than 0. Greater than equal to 0, y equal to the mod of x. Okay, so this is the answer. Try question 15. Question 15 is a lengthy question. Question 15 I'll leave as homework for next class. And we'll jump straight to solve. So all roots of this polynomial are positive integers. A, B, C, and D are not given. You just need to find B. Okay. Do whatever method you like. Either just find all the roots and painstakingly multiply it. Use binomial theorem if you have heard of it. Because knowing binomial theorem will be helpful when it comes to AMC. I'll not say anything beyond this. You just need to do some casework, some guesswork also, and get to the answer. This is homework.
So what is B? Acha, that. Okay, sir.
B is the coefficient of x cube.
Sir, and that is D or 0 what? That what?
This is D.
D. Okay. So 1 D. So please show the question.
One second. I'll bring down question 9 because 9 is the question that I'm going to solve. So those who didn't get any time to solve question 9 can do so. Those who have already solved 9 can keep doing question 15. But I'm going to solve question 9 right now. Okay, Harshit has answered something. Answer not correct. Question 9, I think I have given a lot of time to solve. I'll just give a hint.
Sir, is my answer is correct? Saurav.
For Saurabh, for which question?
Sir, 15.
15 not correct. Anya not correct. But you are on the right track probably. Arav not correct. Okay, 1 second. Jeevna not correct, both of them. Alok not correct, Sanyu not correct, Anya not correct. Okay, I don't see a correct answer so far. Pranshu not correct. Okay. I'll substitute this and then I'll show you what the equation becomes. This will become
So can you
y
wait?
cube upon 4. 1 second. I'll just write down the equation and then do nothing more because so that you can at least verify if whatever you have done is correct or not. Plus
Sir, is my answer is
4y.
correct?
Arav not correct, Saurabh not correct. Four y plus, no, sorry, 4y equal to 2y square plus 1. I hope this is the reduced equation that you get when you put y equal to 2 to the power 111x. Now think what can be done to find sum of roots. Sum of roots of x. Alok not correct. So sum of roots of this equation is, one second, y cube minus 8y square plus 16y minus 1 minus 4 equal to 0. Sum of roots, again, I'll copy the stuff that was written before.
Sir, please explain it again. I don't understand.
Sir, am I correct for 15th?
15th correct, Sumit. Very good. What is this?
Sir, can you check my answer?
Tanu not correct. Arav not correct. Pushkal not correct. Pranshu not correct. So alpha plus beta plus gamma dot 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 is equal to minus b by a. Alpha beta plus beta gamma plus alpha gamma plus dot 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 is equal to c by a. Alpha beta gamma plus other possible 3 at a time product of roots will be minus d by a, and so on. Okay, so this was the substitution that I was talking about. After this, to realize that if you want x1 plus x2 plus x3, how to get it from the possible alpha, beta, gamma that are solutions for y over here?
Sir, my answer is the correct, Saurav.
Saurabh not correct. Arav, again, what you have given answer is probably from internet for the particular question from which I've removed this question. This is a truncated version of the question from a previous paper.
Can you check again?
Sanyu not correct. Jeevna very close, very close. Just check your answer once more. Alok not correct. You just have to find the sum of the roots. Okay. So when you want to find, I'll bring down this question. Let x1, x2, x3 be the real roots of this equation. If you want x1 plus x2 plus x3, the way to get it from y1, y2, y3, where what did we have? Y cube minus 8y square plus 16y minus 4 equal to 0. Let y1, y2, y3 be roots of this equation, where we have yi is equal to 2 to the power 111 xi. Then if I want sum in the exponent, below it should be product, correct? Can I write that y1, y2, y3 will equal 2 to the power 111 x1 plus x2 plus x3? This is the method to solve this particular question. Product of roots below is sum of roots in the exponent of the other equation. So what is product of roots for this equation? This y1, y2, y3 will be equal to minus of minus 4 upon 1, which is equal to 4. And that is equal to 2 to the power 111, x1 plus x2 plus x3. 4 can be otherwise written as 2 to the power 2. So from here you have 111 times x1 plus x2 plus x3 equal to 2. And your answer is x1 plus x2 plus x3 equal to 2 upon 11. Okay, so this is where you have to leave your answer at. The original question was that let this be equal to m by n. And since exams like AMC or AIME, they have integer answers in the end, or AMC does not have integer answers in the end, but they can put options with integers, correct? So just adds a little bit of complexity for like people who are trying to just guess the answer. If this is m by n, the question had mentioned that m plus n equal to what when these are in the lowest terms. So then answer is 113, but the question I asked answer is 2 upon 11. Okay, so you can take screenshot of this question. I'll do one thing. I'll remove the theory from here, put it below.
So can you send the whole PDFs somewhere at the end
PDF,
of the class?
I'll do one thing. I'll make, since I'll be using the same PDF for the same note for rest of the classes also. Whoever joins this seminar, at the end, if you have stuck around till the end, I'll give the link for this. Let me just create the link. Okay, you can check the chat. Where is meeting group chat? Okay, you can access the questions of today's class from the link that I've sent in the chat. Time for today's class is up. Question 15. Is there a hint that I can give? Okay, no hint. Just remember that the roots are positive integers. Okay, positive as well as integers. That restricts the possibility a lot. Okay, roots can be repeating also. It's not that all roots are distinct. They need to be positive and they need to be integers. In that case, you need to find B. Okay, try question 15 till next class. I mean, you have other classes and all to also take care of probably. So 2 weeks later, we'll discuss this. See you guys.
Thank
I'll
you,
end the
sir.
meet. I can't end the meeting, but I'll leave the meeting. All of you can also leave the meeting.
Thank you, sir.